Hello and welcome to part 3 of Required Practical 4, in which we're investigating IV characteristics of various different components. In this final instalment we're going to be investigating the IV characteristics of a diode, and for our diode we'll be using an LED. You'll notice that the setup is very similar to our previous 2 experiments, but there are a couple of slight differences this time. Difference number 1, we're going to be starting with just one cell connected. And instead of using one of our standard ammeters, we are going to be using a much more sensitive ammeter that's measuring down to the milliamps. You'll notice that when we connect the circuit initially, the LED does not switch on. And we will connect the voltmeter in parallel. And you will see, although the LED is not switched on, we have got a potential difference across it. So here's a diagram of this particular practical. You can see we've got a battery of cells here. In this diagram they've added an additional resistor which we've not used. We have a milliammeter instead of our standard ammeter. Our diode, but of course we used a light emitting diode instead. We've got a voltmeter connected in parallel and our variable resistor. If we look at the ammeter, which of course is connected in series, you'll notice that we have a reading of 0 on there. So we will record a potential difference of 1.54 volts and a current of 0 amps. Once you've got your first reading, what I would like you to do is disconnect the circuit, and you're going to put in a second cell. You'll put the cells next to each other so it's easy to see that they are pointing in the same direction, and when you connect the circuit this time you will see that the LED does switch on. We've now got a reading of 2.01 volts, and if I hold up the ammeter for you, you'll see that we've got a reading of 35.9 milliamps. So that is 0.0359 amps. We are then going to take readings in the same way that we have done in all the previous experiments. So we will move the slider on the variable resistor by 2 centimeters approximately. You'll see that the potential difference has gone up very slightly to 2.02 volts, and the current is now at 40.8 milliamps. So 0.0408 amps. Move the slider by approximately 2 centimeters again. See our potential difference has gone up now to 2.04 volts. And if I show you that ammeter, you can see our reading is now at 45 milliamps. So 0.045 amps. Just like before, you will continue to take readings until you have the slider all the way over to the left hand side, and then once you've done that, you're going to disconnect your circuit. You're going to turn the cell around, reconnect your circuit, and as with the previous 2 experiments, you'll see that you are getting negative readings on your voltmeter and your ammeter, and you're going to go through the process of taking the readings again. So we're now at minus 1.53 volts, and our current once again is 0. You can see the LED is not on. We'll add in the second cell. Make sure the slider is right over to the right hand side. you can see we've got a potential difference reading of negative 93. And interestingly, you'll notice the LED has not come on. We still have a current of 0 amps. So we're putting these readings in our results table. We can move the slider by approximately 2 centimetres, and just like before, you will continue to take readings until the slider reaches the far left hand side of the variable resistor. Once you've done that, once again you will draw an IV characteristic graph, so a graph of potential difference against current, and you can use that to show the IV characteristics of a diode.